This slide introduces the topic of types of surveying for the course ARC 207J, Site Analysis and Planning, Unit 1. It features AR Kritika R., Assistant Professor at SED, SERMIST, KTR Campus. This slide details the classifications of surveying, dividing them into plane surveying and geodetic surveying based on whether the curvature of the Earth's surface is considered. Key differences are highlighted, such as plane surveying treating the Earth as a plane surface and ignoring its curvature, while geodetic surveying considers the curved surface and takes the curvature into account. This affects how lines between stations and triangles formed by points are treated, as well as the angles within those triangles. Plane surveying is suitable for small areas, less than 250 square km, and is carried out by local and state agencies, while geodetic surveying is carried out by the Survey of India Department. This slide outlines the classification of surveys based on the purpose of the resulting map. The three types are based on the nature of the field survey, the objectives of survey, and the instruments used. This slide focuses on classifications based on the nature of the field survey. It lists different types of field surveys including land survey, further divided into topographical survey, cadastral survey, and city survey, as well as marine/hydrographic survey and astronomical survey. This slide elaborates on land survey, breaking it down into topographical survey, which determines natural features, cadastral survey, which fixes property lines, and city survey, which is related to the construction of streets, water supply systems, and sewers. This slide explains marine/hydrographical survey, which deals with bodies of water for navigation, water supply, harbor works, or determining sea level, and astronomical survey, which determines the absolute location and direction of lines on Earth's surface through observations of heavenly bodies. This slide lists survey types based on the objectives of survey: engineering survey for designing engineering works, military survey for strategic points, mine survey for exploring mineral wealth, geological survey for determining Earth's strata, and archaeological survey for unearthing relics. This slide presents a classification based on the instruments used: chain survey, traverse survey, tachyometric survey, theodolite survey, triangulation survey, plane table survey, photogrammetric survey, and aerial survey. This slide discusses chain triangulation or chain surveying, explaining it as a surveying system where triangle sides are measured directly in the field without angular measurements. It is the simplest kind of surveying, suitable when high accuracy isn't required, the ground is fairly level and simple, plans are needed on a large scale, and the area is small. It's not suitable for large areas, areas with too many details, or undulating areas. This slide describes two methods of land surveying: triangulation and traversing. Triangulation involves a network of triangles with sides computed from a measured baseline and angles measured with a theodolite. Traverse surveying fixes survey line directions by angular measurement, forming a series of connected lines with lengths measured by chain or tape and angles measured by an instrument. This slide lists the equipment used in chain surveying: chain, tape, arrows, ranging rods, offset staff, and optical square. It also mentions different types of chains such as metric chain, gunter's chain, engineer's chain, band or steel bar chain, and revenue chain. This slide provides details about the chain used in surveying. Length of the chain is 20 or 30 meters, with 5 links per meter, making each link 20 centimeters long. Tallies are placed every 5 meters, and small brass rings are at every meter, except where tallies are placed. This slide describes different types of chains, including metric chains divided into 100 or 150 links, gunter's chain exactly 22 yards long and divided into 100 links, and engineer's chain, which is 100 feet long with 100 links, each link measuring 12 inches. This slide continues describing different types of chains, including the revenue chain, commonly used in cadastral surveys, which is 33 feet long and divided into 16 links, each measuring 2.0625 feet. It also mentions the steel bar or band chain, which is 20 or 30 m long, 16 millimeters wide, and has brass tallies fixed at every 5 m length. This slide lists additional equipment used in surveying: arrows and ranging rods. This slide displays more surveying equipment: line ranger, cross staff, including open, French, and adjustable types, optical square, and pegs. This slide explains the principle of chain surveying, which is triangulation. It emphasizes that a network of triangles is preferred because a triangle can be plotted from the measured lengths of its sides alone. Ideally, the triangle should be well conditioned with angles close to 60 degrees to minimize distortion, but in practice, angles should be between 30 and 120 degrees. This slide describes the procedure for measurement of area by chain triangulation. The area is divided into triangles, the lengths of the sides are measured, the area of each triangle is calculated, and then summed to find the total area of the field. This slide defines a survey station as a point of importance at the beginning and end of a chain line. It distinguishes between main stations, which connect boundaries and are represented by circles and capital letters or numbers, and subsidiary or tie stations, which are selected on the main line to locate interior details and are represented by small letters. This slide illustrates the concepts of main survey line, tie line, main station, and tie station using a diagram, showing their relationship to a building within the survey area. This slide lists points to consider when selecting a survey station, including ensuring mutual visibility, adhering to the main principle, drawing a line through the area's length if possible, using well-defined triangles, providing a check line for each triangle, minimizing survey lines, drawing tie lines, avoiding obstacles, choosing level ground, and positioning triangle sides close to the boundary. This slide defines the baseline as the longest chain line, considered the most important line as it fixes the direction of all other lines and forms the framework of the survey. It should be laid on level ground, ideally through the center and length of the area, and measured correctly multiple times. This slide defines a check line, also called a proof line, as a line joining the apex of a triangle to a fixed point on the opposite side. It is measured to check the accuracy of the framework, providing a complete check on field measurements and plotting work. This slide describes a tie line as a line joining fixed points, termed tie stations, on the main survey lines. It serves a dual purpose, checking the accuracy of the framework and enabling the surveyor to locate interior details that are far from the main chain line. This slide lists the three types of lines discussed: baseline, check line, and tie line. This slide presents the advantages and disadvantages of chain surveying in a table. Advantages include suitability for small land, easily replaceable parts, less workmanship required, simple area calculations, and less error occurrence. Disadvantages include unsuitability for large-scale land, difficulties with obstructions, time delays, less accuracy, and unsuitability for sloped land. This slide introduces traverse survey, defining it as a type of survey where survey lines form the framework. The directions and lengths of these lines are measured using an angle measuring instrument and a tape, respectively. It also distinguishes between open traverse and closed traverse. This slide further explains open and closed traverse surveys. An open traverse ends elsewhere and is suitable for surveying narrow strips of land like roads or coastlines. A closed traverse forms a circuit that ends at the starting point and is suitable for locating boundaries of lakes, woods, and large spaces. This slide outlines methods of traversing: chain and compass traversing, transit and tape traversing, and plane table traversing. It elaborates on chain traversing, where all work is done with chain and tape, without any angle measuring instruments. Directions are fixed entirely by linear measurements, creating what are known as chain angles. This slide describes chain and compass traversing, where magnetic bearings of survey lines are measured by a compass and line lengths are measured by chain or tape. The magnetic meridian is established independently at each traverse station. This method is also known as free or loose needle method. A theodolite fitted with a compass may also be used. This slide explains plane table traversing, which follows the same principle as a transit traverse. At each station, the table is set, a foresight is taken to the next station, and its location is plotted by measuring the distance, similar to the radiation method. It also describes transit and tape traversing, where angles are measured with a transit or theodolite, and distance is measured with a tape or chain. This method allows for more precise measurements and is used for land subdivision planning, construction surveying, and most land boundaries. This slide contains a link to a YouTube video related to the topic. This slide introduces triangulation survey, explaining it as the basic surveying method used when surveying large areas. The entire area is divided into a network of triangles, and the method involves measuring the angles in a triangle formed by 3 control points. Using trigonometry and the measured length of one side, the other distances are calculated. This slide continues explaining triangulation survey. It states that the measured distance in the first triangle is the baseline, which is the only distance measured. All other distances are calculated from it and the measured angles. The angles are measured using a theodolite. Vertical angles are not needed but can be used to measure height differences between points. This slide introduces tachyometric survey, which utilizes a theodolite equipped with a stadia diaphragm. The stadia diaphragm has 3 horizontal hairs and 1 vertical hair, allowing for 3 vertical staff readings at the same instrument setting, lower, central, and top hair readings. The difference between the lower and upper hair readings gives the staff intercept. This method is rapid and convenient and best adapted for obstacles like steep ground, deep valleys, or bodies of water. This slide lists the instruments required for carrying out tachyometric survey, a tachyometer and a stadia rod. It also lists methods of tachyometry survey, stadia hair method, fixed hair method and movable hair method, and tangential method. This slide describes plane table survey as a graphical method of surveying where field observations and plotting proceed simultaneously. It involves making a manuscript map in the field while observing the ground, eliminating intermediate steps of recording and transcribing field notes. It can be used to tie topography to existing control and to carry its own control systems by triangulation or traverse. This slide lists the instruments used for plane table survey. The plane table with leveling head, including arrangements for leveling, rotation, and clamping, alidade for sighting, plumbing fork and plumb bob, sprit level, compass, and drawing paper with a rainproof cover. This slide defines photogrammetric survey as the practice of determining the geometric properties of objects from photographic images. It involves estimating the 3-dimensional coordinates of points on an object by measurements made in 2 or more photographic images taken from different positions. Common points are identified, and lines of sight are constructed to determine the 3-dimensional location of the point through triangulation. This slide lists the components of theodolite survey: telescope, vertical circle, index frame, the standards, the upper plate, the lower plate, the leveling head, the shifting head, plate level, tripod, plumb bob, and magnetic compass. This slide is a title card for the next section. This slide describes the parts of theodolite, focusing on telescope, a focusing instrument with an objective piece and eyepiece that rotates about the horizontal axis, vertical circle, fitted to the telescope and moving with it, graduated in each quadrant from 0 to 90 degrees, index frame, also called T-frame or vernier frame, used to lock the telescope and measure vertical angles, and the standards, frame supporting the telescope's rotation. This slide continues describing the parts of theodolite. The upper plate, also called vernier plate, which supports the standards, contains an upper clamping screw and tangent screw, and has 2 verniers with magnifiers, and the lower plate, also called scale plate, which has a scale with 0 to 360 degree readings, a lower clamping screw, and is attached to the outer spindle. This slide details more parts of theodolite: the leveling head, which contains 2 parallel triangular plates, tribrach plates, with the upper one used to level the telescope and the lower one attached to the tripod stand; the shifting head, which contains 2 parallel plates moved over each other for centering the instrument; and plate level, which helps settle the telescope in a vertical position. This slide covers remaining parts of theodolite: tripod, the stand on which theodolite is mounted with legs having steel shoes for stability and an external screw to attach the theodolite; plumb bob, a tool with a cone-shaped weight attached to a thread used for centering the theodolite; and magnetic compass, sometimes included in simpler theodolites for selecting north as a reference meridian. This slide provides a thank you message.